He says, I hope so. So thanks for coming, and this is a busy time for everybody, the social occasions. Let me give you a little background. As you know, I'm on the same committee trying to put together the program. And Gloria, about a month ago, said, about your recent trip to India, could you tie the geology of India to economics, politics, history, and religion for the next talk? And I said, well, all in one talk? But I said I could. I've been thinking about water problems for a while, and the background is that, you know, I've been away from India for almost 50 years, but we do go see the family, and most of the time, every time we have gone, it's been in the winters when the weather is better. But then last few years, we started having family emergencies, relatives, brothers getting sick or passing away. So 10 years ago, I had to go in the middle of May when temperature in Delhi was 113 degrees. And I took this road trip from Jaipur to Delhi. It's about a 4-hour drive. You'll see where it is. And you go, and tremendous development, big hotels, big factories. But as you drive, the scenery looks like you are going through a set of dunes. It's dry, it's parched, and you say, how's it going to be all supported? And then I came back, you'll see SEG actually had a satellite picture. I didn't even know the satellite gravity data. I always was looking for how satellite gravity looks at the deep structure. But satellite gravity is used in one of the experiments for measuring groundwater level. And now SEG actually has a lot of work presented. So with that background, let me now here, this is the god of hydrology system. I mean, we have a lot of gods, and I don't know if they have one for sequence stratigraphy yet or not, but he is the god of hydrology, and the myth about his powers are that he controls the atmosphere, the water in the atmosphere, which is the water vapors. He controls the surface water, but he also controls the water in the subsurface, groundwater. So as far as I'm concerned, he's the god of hydrologic system. So everybody here knows what the water cycle is, but I'll just give a little background. The main thing about water cycle is that the total number of molecules are finite, and the one we use, it's only available as 0.8% of all the H2O. It's either all saline or even the fresh water. A lot of it is in the ice cover. So it's a limited amount of water, and that's all we have to deal with. So there's a lot of literature you start to see. So it's not just India. I started to look at that as an example, but all of these areas here that at least some of the months in the year follow water scarcity. And as you can see, this whole belt from about equator north, of course, Australia, parts of South America, South Africa. So it's not just India is just as an example, but the water problems are all over. So here is this 12 most water, and then Gloria just came back. Our family was earlier this year in Cape Town in January of 2018, and they were talking about shutting down all the taps by April. But fortunately, it didn't happen because they did get some rains. You'll see a little bit about Bangalore, what's going on. So our daughter was living in Sao Paulo until just a couple of weeks ago. So Tokyo, if you go there today in places like Tokyo or Sao Paulo, Miami, you wouldn't really think that there is a major crisis. But all of these, you look 10, 15, 20 years ahead, cities all over the world are growing, but the water supply and how they manage is probably not keeping up. And I think that's why this crisis came to Cape Town.
It's just a quickie. I learned my geography a long time ago, and I don't know what Bengaluru used to be.
Oh, Bengaluru is
Bangalore.
the new name for Bangalore.
Bangalore, okay.
Yeah, yeah, I'm sorry, they keep changing. Actually, even in my province, all of a sudden they are changing names.
Yeah.
So I'm sorry, Chennai used to be Madras, but
Yeah, I know those of us that, were in elementary school in the
Right.
60s, we're a little
yeah,
challenged.
I know. And even Bombay is now Mumbai, so I can control that. So for India, almost half the population is some kind of a stress. And one thing about what I'm going to talk about is just still a very, very small part of the problem. I won't be able to talk about the pollution, won't be talk about the quality of the water, essentially just supply and demand of the water, surface and groundwater. But there are a lot of problems providing fresh, clean water to almost half the population. All of that is not part of this talk. So here again, one of the things I know every time we have some talk, I have tried to give the metric equivalent in the units that we are familiar with, and if I have time, I'll tell you a story about the units. But the rest of the world follows these units. So the water quality, as I said, I won't be talking about it, is one of the lowest in the world. Drinking water availability is one of the lowest in the world. And you'll see where it is headed. So this is Bangalore. I should have written Bengaluru, but Bangalore, this is June 2018. And the thing to remember, this is one of the high-tech, all the companies that Amazons and Microsofts, all these have very, very nice, beautiful offices. It's a very, actually, compared to other cities in India, we were there just about a year and a half ago. It's a very nice place. And these people here that are waiting for water, they are not desperate, poor people. But this is the way it was at this particular time, this last summer. And half the population and you'll see the definition of water stress in a minute, but by 2025, which is not very far away. So obviously, it's all related to population. So I'll be referring to this as the Golden Triangle. That's Delhi, Jaipur, Agra, and it's referred to, I know many of you have been to India and people go, this is sort of the most visited area in India. And after this talk, I still want you to go to India if you haven't been. You will have no problem. Hotels are very nice. The water is clean. We had some people just come back and nobody got sick on their tour. So what you see here is a crisis, no doubt. It needs to be planned, but as a visitor, it's still a pretty interesting place to go visit. However, you can see that the average population density is not too high. It can be managed, but U.S. average in that relationship is to almost 10 times lower. And you'll see in a minute what has happened to this population since independence. So at the time, just after independence, we are talking about 360 million people, and now 2050 is about going to be 1.7, and I think when they pass the Chinese population is somewhere here, because India has had, they have never had a one-child rule, and that has its own problems, but Indian population is still increasing. But when you get to this level, that's water scarcity, and again, you can convert 264 times 1,000. That's sort of the scarcity line. This is the stress line. We are already there. So at the time of independence, it was a very poor country. It still is a poor country. But currently, if you look at just purchasing power parity, Indian GDP is number 3 in the world. China actually has the highest GDP on a PPP basis, then US, and then India. And even in terms of dollars, Indian GDP is number 6. So it's still a poor country, but compared to where they were at the time of independence, they have done tremendous progress. People are living longer, life standards have gone. However, there is a downside of that is as people live better, they eat better, you need more food, you need more roads, you need more transportation. So even when you think you are doing something good, 20, 30 years down the road, the same things that were doing well start to cause their own problems. And we'll talk about that in a second. So the rainfall overall is about, again, 47, 48 inches. However, if you remember, this is the part where the population density is one of the highest, and this is where the rainfall is actually, and you're right near Pakistan border, so this is sort of the near the semi-desert area. Of course, you have here a lot of rainfall. Again, somebody was asking about Kerala. A lot of rainfall there. They just had big floods just recently. So we'll be, since this is the part of the country I come from, I'll be talking about this area primarily, and that's where the biggest concern about water availability and how it is being used is right now most prevalent. So again, being a group of geologists, we have the mountain chains here. This is the part of the basalts, Deccan basalts. Southern part is all crystalline. So this part here is where we have the very, very thick, in the foreland in front of the mountains, you have 4, 5, 6 kilometers, 20 to 30,000 feet of alluvium. So obviously these aquifers are pretty, you'll see again what kind of delivery they can provide. But out here, these are major river valleys, so you have unconsolidated aquifers in these areas. But where you have the cratonic and crystalline, you do have fracture porosity, but the soil cover and the aquifers are not as extensive and not as capable of holding water volume as some of these aquifers are in the north. This is again measures the groundwater potential in liters per second or gallons per minute. And you can see again, these are the ones at 40 liters per second. So these are the highly productive aquifers which can produce a lot. The rest of it are in these river valleys, but if you are out here, they are okay, and I think even in this range, but you have to then manage in terms of what the drawdown is as opposed to versus how they are being replenished. And that's where the problem is. You'll see in a minute the water balance. It's not all that complicated. It's like our retirement planning. You know, you have to say what percentage we can take out of our savings so that we can die before we run out of money. Same thing, how much groundwater you can withdraw before you start to lose the storage in the ground.
Naresh?
Yeah.
In the South, isn't one of the other problems that there isn't that much relief to the topography, so it's very difficult to build any dams to store water?
Yeah, well, I'll come into the dams and the water connectivity system in a minute, but there is relief, as you know, you've been there. I mean, the central plateau, but then you come pretty steeply right down to the two plains area or the two parts on the east side. So, however, the dams, you know, in the 50s, 30s and 40s and 20s in the United States, I mean, we built those huge dams. And when India got independence in the 50s, they thought that would be the way to store water, flood control, agriculture, all of that was needed. And as you know now, even in the US, we are going away from these big, huge, giant dam kind of projects because one of the things you'll see later, I say, no good deed goes unpunished. And in economics, there is a rule they talk about law of unintended consequences. In other words, no matter what you do, there will be some consequences, things you think are wonderful, what we are doing today. And the smartest people, it's hard for them to predict 30 years down the road. We were talking about that, 40 years down the road, what it's going to do. So, again, you don't have to read the numbers, but the thing that you need to look at, this is the demand in cubic kilometer. Again, 1 cubic kilometer is 264 billion gallons. Main thing to remember is irrigation is almost 10 times what you use for domestic purposes or industry. And even in US, if you remember, when they were having water crisis in LA, it turned out that the almond farmers alone were using more water than the whole city of LA. But, you know, it's an agricultural country, they need water. There was, during the British days, they developed in the north canal systems, but majority of the country was primarily dependent on just natural rainfall, and if you had drought, you had a big famine.